we're going to solve for the power series solution, but this time we do not actually use the power series. Uh, we need to know a lot of things about the power series to do this problem though. First, we start with the Taylor series. I just write that quickly though. To approximate the function y of x, we're going to evaluate that x naught plus derivative x minus x naught, second derivative over 2 factorial x minus x naught square, and then so on. But this time, the power series at x equal to 0 or x not equal to 0, so that will simplify a lot of things. In that case, what we have is the Maclaurin series. So instead of writing like that, we're going to write just the function at 0 plus derivative at 0. We can write x minus 0, but that's not necessary, so just x. And then second derivative divided by 2 factorial. So that is the Taylor series or the Maclaurin series, center 0. And then we will write a power series, and then we compare the two. Y of x we can write as a sub n x to the n power. If we're going to write out a naught, a1x, a2x squared, a3x cubed, and so on. What we do after that is we just matching that. So we say the function at 0 is equal to a naught. The derivative equal to a1. The second derivative divided by 2 is a2. And the third derivative divided by 6 is a3. Right. So we have that. So all we need to know is the derivative of the function, and then we can find the coefficient. To do that, we don't have to go to use the power series. Right. The reason we go only up to a3 because this the solution we only need to go to up to x cubed. If we have to go to the higher powers like x to the 4th and 5th, this solution might not be the best solution. Then we will have to go back and use the actual summation to work this out. But if we only need the first few terms, this solution will work just fine. Only works for the first few terms. Otherwise, it will not be doable. So we start with the original equation like this. All right. We know that x naught is equal to 0, so we have to know that. Meaning that x equal to 0. So this x goes to 0, and we have 21 y double prime plus y equal to 0. Furthermore, that it works for every x, it certainly will work for x equal to 0. Right. So we can say second derivative equal to negative 1 over 21 times y. Like I said before, it works for every x, so why don't we choose x? to be 0, and that's what we have. Now, we did say a y naught y at 0 equal to a naught, so this equal to negative 1 over 21 a 0, because a0 is y of 0. Right. And then we need a2 though. a2 is the second derivative divided by 2. So we need to do is divide both sides by 2. We have a2 is the second derivative divided by 2. So we have this divided by 2 becomes negative 1 over 42 a naught. Right. So we did find that without the power series. I mean, with the power series, but without the summation. Right. Next, we start with the original equation, though. Now, if we take the derivative with respect to x on both sides, the first term is the product rule. So we're going to have 2x, y double prime, and then x squared plus 21, y triple prime plus y derivative equal to 0. Right. And then, of course, x naught is equal to 0. That allows us to cancel this term and the x squared there. To put things together, we should have 21 y triple derivative. And we can solve for the third derivative, negative 1 over 21 times the derivative. Like I said, it works for every x, so why don't we choose at x equal to 0, and we have that. Now we do have derivative is going to be equal to a1, so we're going to substitute a1 in that, and we have negative 1 over 21 a1. Right. We're looking for a3 though. So a3 from here. a3 is equal to the third derivative divided by 6. So we're going to take this divided by 6. 21 times 6, that's 126. And that's what we have for A3. And that's all we do, really. And then we write the solution. Y equal to A naught, A1x, A2x squared, A3x cubed. And we just put everything we have. A naught is A naught. A1 is A1. A2, negative 1 over 42. X squared. And A3, negative 1 over 126. X cubed. Now, even though it looks nice and all, but like I said before, this will work only for the first few terms. I should say it only doable for the first few terms, because if we have to take the derivative of this a few more times, the product rule here will get very complicated, and that will be just get more and more. And that's why we have to go back to summation. The summation solution, even though it's complicated, but it works a lot better when we have to the higher term. But this time, since we only need the first three terms, the first few terms, we definitely can just do this, and we don't have to worry about the summation. This is another solution that I found in an older book. So if the summation solution are complicated, you can always do this. But then again, it only works for the first few terms. So let me zoom out and so we see the whole problem and I summarize what we did. Right. So pretty much we just compare the power series and the Taylor series. And in that case, we're just matching the terms and we end up with that relation. And that relation, we start with the function, the original equation. In that case, we can solve for y double prime, the second derivative. Next one, we need the third derivative. So we have to take derivative from it. And now we have the third derivative. And when we can solve for that, so for the third derivative, then we can have a3. And if we have to find a4, then that will be the fourth derivative divided by 24. But like I said, when we take derivative with all the product rule, it will get a lot more complicated later. But if we go only up to x3, that's good. We can just do it like this.